Hi, this is Roman, and today I'm sharing a Desmos activity that I modified from Illustrative Mathematics for Unit 7, Day 2. So you'll see here I'm in the teacher page, and I'll share the link, and you can modify this to your pleasing. Um, the first activity is a matching activity. So as I go to the preview page here, students would match the corresponding images. So it'd match the picture of a chord to the name of the chord, and then they'd be looking for the definition. So here I see a chord of a circle is a line segment, both of whose endpoints are on the circle. So they would just match them up like so. Um, and here I have an arc, and there I have a central angle, and let's see, the part of a circle lying between 2 points on the circle, that would be an arc, and an angle formed by two rays whose endpoints are the center of a circle would be the central angle. So this is a great investigation activity and a launch for students. They can match the corresponding images, definitions, and names. And then following this, if you give them the answer key, they can compare their definitions to check for precision, um, which is from Illustrative Mathematics and a great tool for discourse. The next activity would be a noticing and wondering activity. And actually, I notice here that I did not write, what do you notice? So what do you notice and wonder about the image? We have a sketch tool here. So the first activity is very interactive with students, asking them to create a diameter in blue. So I'm clicking the segment portion here, and I'm creating a diameter in blue. And if I go to red, I can create a radius in red as a sample, and then keeping it very open about what they notice or wonder about the given image. And based on this discussion and these noticings and wonderings, you could build on that with this next activity, which has students place a check mark on statements that must be true, can't be true, or could be true. So the first statement here is the diameter is a chord. So the way that students would do this part is using the sketch tool, just place a check mark. A diameter must be a chord. And then you can gather student responses from this sample. So from here, the next tool would be an investigation portion for the lesson. Desmos does have a construction tool, not as nice as GeoGebra, but it has its purpose when you want everything in one platform. So here, it's just like the illustrative mathematics lesson with GeoGebra, but it's just all in one platform. They can move point A, and you're noticing that the central angles and the chords are staying the same length here. And they can do that with point D. And those are the two questions about chord lengths and central angles for this activity. I will point out, as a teacher, let's say you really love some activity from Desmos, and this is a side note on Desmos. So let's say I love slide 6. I could press Command C for MacBooks, Control C for Windows, and if I press plus and I paste it, it'll just paste that exact same slide right there. So this construction tool, it's very hard to get into a Desmos lesson, but you can just copy and paste that slide, and that works for any formatting that you fall in love with in a Desmos lesson. And you can make it your own. So I'm gonna get rid of that because that's the same screen as in screen 6. And as I moved on with this portion, my third question I actually rephrased from the illustrative mathematics question. And what I did was I gave them the definition of a central angle. I'm telling them that a central angle will be equal to the arc it intercepts, and then ask them what would that imply about the length of the chords with respect to the relationship of the arcs that they intercept. So that is a way for them to put all those facets together. Following from this example, we have a few assessment ideas that come from illustrative mathematics and UVisions. This first one's from illustrative mathematics, and we'll notice that It's a scaffolded version of the question that's asked on illustrative mathematics. So in this question, I formatted it to give students a few statements and reasons and only fill in the blanks to come to this proof. And this is a great way to gather data as student responses start coming in through Desmos. You could really identify misconceptions to which statements or reasons students might not be getting. And then the next few questions are really spiraling ideas to incorporate prior content taught. And these questions all come from New Vision. So this first one really focuses on the idea of central angles being equal to the arcs they intercept. Our next question starts bringing in this idea of isosceles triangles being created by congruent radii and how to use them to solve. And again, I use the sketch feature here on Desmos. So if I'm a student, I could sketch angle C, right? I could write angle C is 40. If I know this is an isosceles triangle, angle B is 40, which would make angle A 100. And since this is a central angle, I could make arc CB equal 100. Now, what's a cool feature here for students? You can use this beta calculator, and if students need some help calculating, so if I do 180 minus 80 here, they could use a scientific calculator all within one platform on their lesson, which is very convenient for them as students, not to flip back and forth between an iPhone or possibly another application. So here in this question, if I read it, it'll say in the circle shown, chords TR and QS intersect at P, which is the center of the circle, and the measure of angle PST is 30. What is the degree measure of the minor arc RS? We have vocabulary in there for minor arc. We have the appearance again of an isosceles triangle created in this circle. So great review for students. And here, if I utilize the calculator feature, right, I could identify that angle T here is going to end up being 30. So angle TPS would be 180 minus 60. And in this case, I think we're asked for minor arc RS. This is reviewing linear pairs. So we could say that angle RPS is 180 minus 120, right? And if I do 180 minus 120, I'll get my central angle there for RPS, which is equal to my minor arc. So much going on in this question that I think it would be important to have students explain their thinking in this question, which is why I added that. As I X out of this to the teacher version, right? If you don't want to add that, unclick this, ask student to explain their answer, and they won't get that option. There's only one more question. And again, this is really just to highlight the qualities of Desmos. So a lot going on in this question. This question, given circle C with diameters JR, KQ, and PL. PL is perpendicular to JR. It might seem a little more wordy because that was really just the perpendicular symbol for the original question. And KQ bisects PCR. We have angle bisectors, perpendicular lines. We have an open-ended question and a table. I love using tables for students. So, for example, here, if a student writes a calculation and presses enter, it'll give them that solution, which is very cool. One thing that I do want to point out, if you decide to put an equal sign, it doesn't work. So you want to mention that to students. Some students aren't getting any responses. Just tell them to erase that equal sign before they try to enter a calculation. And this is very helpful because they could do more intense calculations here to solve for different measurements. So this is the sample of the Desmos lesson that I modified. On the next few slides are the rest of the illustrative mathematics assessment questions and summary. What I do want to point out here, I'm going to click publish. And as I click publish, I'm going to be sharing this link. And this is a created activity that anybody could use. What you're going to do is once you get on this screen, you're going to click the three dots on the top right and click copy and edit activity, and you could make it your own. And if you don't want to change anything, you could just make it your own link. Also, here we see the assign button. If I click assign to your classes, linking your Google Classroom is one click, and then you could just click the classes you want it to go to, and it'll post automatically to your classes, which is very nice as well. So this was on Unit 7, Lesson 1, Lines, Angles, and Curves.